So good morning. My name is Gopala. I'm the product manager at VMware. I focus on cloud native storage, Kubernetes, modern databases, and other topics. So thank you for coming. The topic that I'll be discussing today is modern databases on cloud native storage. The way I have structured this discussion is that I'll first motivate the problem. What's the problem that we're talking about? Why is it a problem? I'll then go on to talk about what the challenges are, what are we doing in the community to address some of these problems, what are the best practices that customers need to be aware of today, and finally, I'll end it with what VMware is trying to do to address this. So when we refer to these modern databases, this is a very broad term. So this might either mean applications like Cassandra, MongoDB, these modern databases, or it could be other stateful services like Redis, Kafka, and so on. Right? So in some ways, all of these different applications share a similar design and architecture, which is very different from their traditional counterparts. So when you look at these applications, they are frequently designed as shade nothing applications. What that means is these applications manage the availability in their own layer. They do not depend on the storage layer to offer them this replication and resiliency. Secondly, these applications have slightly different availability semantics when it comes to making your data available as compared to your traditional storage platforms. For instance, your Cassandra could be replicating data differently from the way your MongoDB does or your S3 object store does. The other thing that we notice with these newer applications is that they're frequently these complex aggregate of different services and functions. So if you take Cassandra, for instance, you have different instances. Some of these instances could be stateless, some of them could be stateful. So the way you manage these different instances is very application specific, right? So your administrators need to understand how they manage it, and that's the reason day zero, day two operations are pretty involved. You will have to train your admins to understand a specific application and then manage them. Right? So, what we also see is customers are trying to deploy these applications on their existing infrastructure, virtualized infrastructure, when they deploy it on VMs, and they use traditional storage platforms to deploy them because they have their other applications that are deployed on these traditional storage platforms. So when they do that, there are a couple of different challenges that they face. So for one, when they have to think about availability, it's frequently a difficult problem for them because these applications, as I alluded to, do not have the placement control on these newer storage platforms. So as a result, you cannot only rely on your application level replication because that will kind of, your availability semantics will be violated because there is no placement guarantees. On the other hand, if you choose to do a dual replication on your application as well as your storage, you incur higher costs, right? And storage is pretty expensive. So customers frequently bring that challenge up to us. On the operations management, what we find is that because of these involved operations and semantic awareness, you would have to train specific staff to understand how to manage and operate these applications, which is usually a manual task and leads to higher costs. And again, there is no visibility into these application semantics in the infrastructure itself. So troubleshooting, traceability, monitoring, all of those are challenges for customers today. So when it comes to data protection, when customers have different types of applications deployed, they would still need data protection for these newer applications that are using these modern databases. That also is an unsolved problem today. Primarily because the state is distributed across different instances, and the way you think about data protection is very different when you have a distributed stateful application like these newer databases. So those were the problems and challenges, right? So how are we thinking of solving these? So it turns out Kubernetes does a very good job in helping some of these things. So there is a concept of this Kubernetes Operator, which allows application developers to encapsulate the different day 0, day 2 operations and automate them so that you take away the manual aspect of deploying and managing these different applications. So what this also allows application developers to do is to leverage some of the infrastructure smarts that are available on certain infrastructure platforms, and tune their operator to use those smarts and make those applications behave well on certain infrastructure platforms that offer these kinds of smarts. So what we are doing is we are working with the community in getting these Kubernetes enhancements proposals out. So the idea behind these enhancement proposals, also called KEPs, is that you extend your Kubernetes technology and the APIs to help some of these newer applications have more control over how they place their data on these platforms, as well as listen to certain events that are coming up from these platforms so that they can automate some of these tasks in their own layer. So the first KEP that we're working on, it's the storage pool API. The idea here is that you introduce a concept of a storage pool within Kubernetes, wherein your applications can decide which storage pools they go and deploy their data or replicas so that they can be aware of the different failure semantics on the underlying infrastructure, and they have better control over how they place this data, which essentially means that you can be completely relying on the application level availability without having to worry about turning on your application or availability on your storage platform. Right? So we expect the application developers to integrate their operators with the infrastructure by using some of these KEPs that we are thinking about. The other KEP we are working on is this concept of bubbling up your infrastructure events through this health monitor extensions. The idea again here is that your operators will listen to these events and automatically take some of the actions that will help your application react to certain kinds of events in the system. For instance, if you have a resource that is going away from your infrastructure, such as maintenance or decommissioning operations, your operator can listen to those events and then build in that automation that is required to keep your application remain available even after these kinds of events happen in the cluster. So we have engineers here in the room that are working on these KEPs. So if there is interest, please stop us. We will get you to talk to our developers, and we can have a productive conversation. So those are all things that we are looking at to do in the future, but we have customers that are looking at these deployments today, right? So we will need some kind of best practices for these customers and give them some ideas as to how to think about these different aspects of managing these databases. So to that end, so here is how we have these conversations with our customers, right? So when customers are looking at these databases, we essentially talk to them about 3 areas that they need to be thinking about. The first area is how do you think about placement and availability, right? So when you are deploying your Cassandra or MongoDB databases on your storage platforms, how do you think about availability? So our recommendation to our customers at this point is that they turn on the availability in both your database as well as your storage layers, primarily to keep your availability guarantees guaranteed at all the time, right? Because you cannot only rely on your application because of no placement control. So that's the only option that we have today to make sure your applications do not suffer a loss of availability. This will obviously have a higher cost, but that's the price that you pay to keep your availability as well as your operations simplified. So this also lets customers consolidate their different workloads, both your modern and traditional workloads on your storage platforms, and not to worry about having a separate cluster or a resource pool for your newer databases. So when it comes to operations management, one thing we always tell customers is if you have chosen to do availability only in your database layer, you should plan well ahead for your data operations, like your maintenance or decommissioning tasks. This is because it's not enough to just let your infrastructure move data or move replicas or data out of the particular nodes, but it's also important for you to be aware of what application data is residing on this particular node so that you manually move that out before you start any of your infrastructure maintenance operations. So this is quite an involved task, and it requires application awareness. But until we do some of these improvements that we're talking about, that's, I think, the only way that you can ensure data availability even after you enter some of these maintenance tasks. On the data protection, what we tell customers is if you have your Kubernetes containerized databases, you should be using the community offerings such as Velero and Restic to go and take backups of your namespaces for your Kubernetes applications. Those are all open source tools that we have. But if you have traditional virtualized based deployments, you should use your existing backup software to go and take backups of your block devices that are backing your VMs that are running these databases. There is also a choice for you to use a DB-specific data protection solution. Cassandra, MongoDB, all of these databases offer data protection. But the problem with that is you'll have to train your staff to understand specific semantics of data protection for those applications. One other recommendation that we have is if you have a large deployment, if you have several petabytes, tens of petabytes of data in your databases, we would recommend that you consider replication instead of backups. So in the last few slides, I want to touch upon what VMware is doing to support these databases deployments on vSphere. So for one, we released our cloud-native storage platform as part of our 6.7 update 3 release, which went out in August of this year. As part of this release, we also did our first CSI plugin for vSphere with support for all the different storage backends for vSphere. So we support vSAN, VMFS, NFS in this particular release. So with this, what customers will be able to do is they will be able to deploy block-based persistent volumes for your Kubernetes applications on any vSphere storage backends. So with this, you would also be able to deploy all of these newer databases, the containerized Kubernetes versions of these databases. We have solution guides for all of them. So we would encourage you to go onto Storage Hub for VMware and look at these guides, which will tell you how to deploy and manage these Kubernetes-based databases on vSphere, CNS, and CSI. We also have a feature called vSAN Host Affinity, which is in its limited availability mode right now. So the idea here is that if you have deployments on top of vSAN, we allow users to use a policy called Host Affinity, which will let customers pin their storage to the node where your compute is being run. So this is essentially, if you go back to my previous slide wherein I talked about shared nothing applications, when customers want to have the ability to turn on availability only in their application layer, and they want the determinism for placement for those applications, we allow these application developers to use a specific policy called Host Affinity, wherein they can get the coupling between your compute and your storage. The reason this is in limited availability right now is that we do not support a lot of different situations like mixed workloads. You are not able to run your virtualized and your non-SNA and SNA workloads on the same cluster, and there are certain other caveats. So we do not generally make this feature available, but if there is interest, we would ask customers to talk to us, and we would approve those use cases based on the actual usage of this feature. So here I want to touch upon how we think about data protection for modern databases. So frequently, the one thing that comes upon is that the question that customers sometimes have for us is, they wonder if there is a need for data protection for these modern databases, right? Because they say that, hey, these modern databases do the availability and replication in their own layer. So is there a need for you to go and protect these applications? So this is a common misconception that we always see. And one thing we always tell customers is that data protection is different from data availability. Right? So data availability is how you make sure that when your application is running, normally you have certain failures that happen in the cluster, and your application can still go on with other replicas that are present in the same cluster. But data protection is about insurance against loss of storage, right? Loss of workload. So you have a disaster that strikes, and you need to go to some other repository to get your workloads back up. So data protection is still a key part of these modern databases. It's an aspect that customers need to think about. And that is the reason we are working with a lot of partners. We have an in-house Velero offering, which is community-based tool. We are working with vendors like Dell EMC, PowerProtect, as well as Kasten in getting these end-to-end data protection aspects considered for databases. Right, so Gaurav has a talk soon after me, wherein he's going to come and discuss how we both are working together in offering this for customers, for this end-to-end database protection for customers. So that is all I had. I have time for questions. So if there are any questions, I'll be happy to take them. If you want to see, we have a few demos that we have planned. So if you want to see those demos, we can show it to you at our mini booth. But if there are questions, please feel free.
And I will bring you the microphone so everyone can hear the questions. They weren't ready for that. No one else has given them the opportunity. Questions? Come on, you guys had a bunch of questions out in the back, but everyone's too shy. Here we go.
Question there.
One question in the corner. Can you?
So with your new CSI driver, what is your support for external storage arrays then? Because it seems like it's primarily focused with vSAN.
Right.
And so some of the questions that I saw is you have vSAN, but then you also have VMFS. You also have the NFS, and so it's just a little bit muddy as to how that integration goes there.
Right. So our CSI plugin is not just vSAN. We support all the different storage backends, vSAN and external storage, as part of our CSI drop. You can have VMFS, NFS-based storage, which is also supported by this CSI driver.
Support SPBM then through that as well, or?
So SPBM is today only supported on vSAN, but other storage is non-SPBM currently.
One more question here.
What's the minimum version of VMFS for this to be supported, and is it supported on vVols?
Right, so there is currently no support for vVols. VMFS, there is no specific version. It works with whatever the latest VMFS version that you have, it should work with that.
Any more? We can probably do one or two more questions. Okay. Well, then we will.
There's one last question there.
Do you support dynamic provisioning?
Yes, dynamic provisioning is supported.
Okay.
Okay. All right. Thank you.
Please say thank you to Gopala. Thank you so much.